So is everybody ready? And so let's start with our today's speech about our Operator Bridge and visiting Omni workshop. And I'm so happy to be here. And first I make an introduction about myself. And my name is Jusen. I'm the tech lead from Operator Finance. Oh, is the voice clear for you? Okay. Great. Yeah, so let's start it with our today's schedule, and there are 4 parts. And the first part is about a quick overview of our Operator team, and I will introduce where we study and where we going to. And the second part is about some technical introduction about the Operator Bridge, how we operate our bridge in a decentralized way. And the third part is about our protocol upgradation from bridge to Omni cross-chain infrastructure. And the fourth part is introduction about our Omni cross-chain workshop. And where we started, and our bridge is when in the 2021, and there were many rollups are launching from the Ethereum ecosystem, right? And at that time, there is a strong demand that the users might need a secure layer 2 bridges on the rollups ecosystem. And at that time, Vitalik has a write-up about the cross layer 2 bridges, and he hold a cross layer 2 bridge on the Gitcoin. And our team got 16S from Vitalik. And this is what we are now, the Operator decentralized bridge, and we initiate on Ethereum as this decentralized cross-roller bridge. And we provided a secure, fast, and cheap for the product. And now we have 4 million user base, and we have 18 billion transaction value. And now we totally handle 30 million cross-roller transactions. And this is something like a yellow paper about our Operator Bridge protocol, and we released them in the 2023 June. And this is kind of a technical architecture about our bridge, and there will be some 2 parts. And one is the correct pace process, and another one is the dispute resolution process. And there are some many components about the off-chain part and some on-chain part, like the smart contract. And also we have our ZK components, like the ZK SPV, and I will elaborate to you guys in later. So this is how a regular process. When you click our cross-chain dApp button on, and this is how we go, this is the flow it goes, and the sender send and transaction on the source chain. Yeah, that is his intention is that he want to transfer one ETH, something like from the source string to the depth string, right? That is his core string intention. He sent his token set to the maker, and when the maker have his off-chain components, and he will monitor this something like this events on the smart contract, and when he got this event, and he will pass this event, and he will manage this transaction, and when he got this instruction, and he will and the maker will transfer the amount to the user on the destination chain. That is a regular process. And so this is something like an optimistic way, right? Yeah, because the standard trusts the maker that he will not do any malicious behavior on the off-chain, right? But what if the maker do some malicious behavior, and he will get a challenge process? That is the and we have a ZK component here. That means you need to prove the transaction on the off-chain with the ZK circuit, and we'll verify it on the Ethereum layer 1. So our security model is all based on the Ethereum layer 1. That is the most important part of our protocol there. And this flow seems like not so clear to you guys, right? And in the next part, I will introduce our technical with some very detail. Yeah. And as I mentioned about the ZK SPV, I thought I'm not sure what any of you guys have read the Bitcoin white paper. Yeah, and that's our idea is greatly inspired from the section A of the Bitcoin white paper, and this called SPV, and this is full name is the simplified payment verification here. And that means you don't need to run in a full node to verify the payments, right? And you just need to keep a copy of the block header of the longest proof of work chain. That is the SPV part from Bitcoin. But when it comes to the layer 2, we will use this kind of the technical in our protocol. And SPV has been widely used in some wallet clients. They help the users to quickly validate the transaction in the wallet UX, right? And first, I would like to introduce some previous knowledge about how a layer 2 works. And every layer 2 will periodically commit their block state on the Ethereum layer 1, and they will accept the user's transaction on their RPC, and they will construct their own word trial and the recipe trial and the transaction trial. And it works just like Ethereum, right? And they will collect batches of the transaction, and they will compress all of this kind of the transaction into some batch, and they will compute this kind of batch into the block on the Ethereum layer 1. And so how to validate the layer 2's transaction on Ethereum? That is the very important part. So let me take an example. And now Alice sent 1 ETH to the Bob on layer 2, maybe Arbitrum or Optimism or ZiggySync. Yeah, I know the transaction really happened on layer 2, but I want to verify the transaction on Ethereum here. So, and now Alex sent one ETH to Bob, right? They've got this kind of transaction on the transaction trial and the recipe trial on the data structure, and they will be compressed into the batch on the Ethereum, right? And this is the fields of the data structure, and this is some kind of the nouns to address value data, VRS, and status code and gas use. I thought if you have to read the Ethereum yellow paper, and you might be familiar with this kind of data structure, right? So, as I mentioned, I take an Alice to Bob example, right? And Alice address is on the VRS field. This is kind of the signature, and Bob's address is on the to address, right? And I want to know if this kind of the transaction have executed successfully, and I can use it. I can check the status code. If that is true, so the transfer is success, right? And how they and the nouns to address and blah 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 and other kind of the fields, they will construct it to the TX hash, and the other fields like status codes and gas use, they will be do some hashes like catch 256 and into the recipe hash, and they will construct it level by level there. And they will got a TX trial and the recipe trial now, and finally they will got a block hash and on the layer 2. That is the data structure on the layer 2, and they will finally combine into the batch hash. And I want to know how many of you guys have written Ziggy circuit, and if you have the experience of writing a Ziggy circuit, you will know that there's some maybe you have reused the circum Ziggy stack, right? And they will have some fields like public inputs here, right? Public inputs in here, right? It means that when you verify the Ziggy proof on the Ethereum, and the public inputs and the verifier can use can see the public inputs like the Bob address and one ETH address and the Alice address and the transfer success here. So when we generate a transaction proof in an off-chain component, and we will send this kind of the Ziggy proof to the Ethereum layer 1, and we will know that the Alice has transferred the Bob address successfully, right? So this is kind of how we implemented the Ziggy SPV for layer 2, and most of the layer 2 work just like maybe they have some different data structure, or maybe they have a more sustained data structure here, but they are basically like got the same data structure in a high level. Yeah, and we implement this kind of the SPV with the Halo2 framework, and this is the ZKP verification gas is about 0.35 million gas, and the proof time is about 300 seconds. And one more thing I want to say is that why we choose the Ziggy stack to implement SPV, because there is a limitation on Ethereum, right? And every block only have the 3 million guests, right? When this kind of computation very big, and you cannot implement it, this kind of computation in Solidity, because even you can implement it, but you cannot run well in the Ethereum. And also we are we are very care about our security of our orbital bridge, and this is kind of co-research with some academic institution, but it's now still in a state of draft. But we will release it in maybe one month later, and this kind of academic institution, they do some formal verification for our cross-ruler bridge, and means that they will construct a mathematical model to evaluate the security of our bridge. And so all I have to say is about the bridge, and now we'll talk about the Omni execution layer. So the token cross-chain are doing well now, yeah, because there are many kind of the cross-ruler bridge in this industry, right? But the real demands is not only include the token transfer, and this is a kind of our Omni cross-chain infrastructure on the Ethereum, and it can support any kind of the message transfer. So the Omni dApp developer can define their own business logic based on our cross-chain infrastructure. So it can only not only support the ERC20 standard tokens cross-chain, and it can help you build an Omni NFT project, or other the Omni GameFi or SocialFi here. And we launch our, and this is how we work, how our Omni-chain infrastructure works, and we will launch we deploy our launchpad and landing pad contract. That is the officially contract deployed by our protocol, and every rollup environment will have its own launchpad and landing pad contract. Launchpad means that you want to send a message from a rollup A, and when you want to send it, when your intention is from rollup A to rollup B, right? The message will be sent from launchpad on rollup A, and it will be received by the rollup B's landing pad contract. And every transaction will be aggregated to our visit station, and visit station here means that is a kind of a ZK rollup, and every cross-chain transaction will be proven by a ZK EVM, and it will be submitted to the Ethereum layer 1 here. And this is the more technical parts, and we have published it on the ETH research. And let me see. Yeah, you can have a quick review about this, and we will introduce our support feature here, and our decentralized model, and our security model, and our efficiency model here. And this is some core function about like the relay contract and launchpad contract and the landing pad contract here. So now I will introduce the use case on our Vizin clustering infra, and let me open the Vizin. And this is our official site here. And as you can see, and now we have some ecosystem partner with our in our environments. And I will take this kind of example, like the liquid. Yeah, this is our partnership. And this is kind of omnis web in our built based on our clustering environment, and it's like a Mimi token launchpad on Ethereum. That means you can deploy your Mimi token on any rollup environments, and you can mint on any environment, or you can burn on any environment, and you can trade your Mimi token on any environments here. And this is the kind of their framework, how they work based on our Vizin chain. Yeah, you can see, and the users can buy or send liquid Mimi token on their official contract, and they will send their clustering message based on our infrastructure. And the user can, and the users on different layer 2 network, they can communicate with each other in a very easy way. And the second project I will introduce is that 0x Astra. And this is kind of omni game file built on the Vizin, and this is kind of a very cross-chain game, and you need to collect the materials or any other kind of components on different chains. And this project runs very quite good now, and they have just finished their series round fundraising, and they have raised $3 million. Yeah, and you can have a try on this, if you are interested in the. Yeah. Sorry. And the most important I want to tell is that the benefits, why you need to build on Vizin, and because we provide 10 seconds for clustering protocol. Yeah, that means if you want to send a message from Arbitrum to ZiggySync or Optimism, you just need to wait 10 seconds. And our team we will share 50% of our protocol fee to the builder on the Vizin environments. And last but not least, I will like to highlight that we are holding an hackathon and our grant journey, and that is we will hold it in Hong Kong, but you can also attend this hackathon online. And this kind of the hackathon will you can just write a proposal, but the proposal should be an innovative for this industry, you cannot just copy something like Uniswap V2 or V3 and submit the proposal to us. Yeah, if you choose the proposal way and the standard will be higher than a workable demo, and we will hold a grant program for 1 million for the ecosystem builders. Yeah. And you can scan the QR code to get the details. Also, I can wait. And this is our Hexon website on the Luma, and this is this is our official article about announcing the 1 million grant program. And also, something I might forgot to introduce to you, and there is our developer docs. Yeah, and you can, and our developer docs are quite ready well, and you can see the architecture in about our product, and you can know you can learn how they works in a technical way. And this is our security model, and you can get the official contract address here. And there's some other demos like we have prepared for you. And this is like kind of the Omni NFT here. Yeah, when you want to create an Omni NFT, so if you want, if this kind of NFT is something like a native NFT, like only mint on Arbitrum, and we can also support this kind of the features. And this is the fungible token here. And this is a cross-chain. This is a Omni ERC20 transfer here. Yeah, there's some demo code here. You can just copy from there and you can run. And this is the demo repository here. It's very easy. You just need to clone the code from our GitHub repo, and you can just npm install, npm test, npm deploy. It's very easy. Yeah, we also provide our SDK in the like my SDK stock. Sorry, we might miss something about the SDK introduction, but you can find on this. This is kind of SDK here. Yeah, this is kind of the SDK, and you can use this SDK into your Omni project directly. And And we'll have our following session in October 17, and we will that will be a more technical part about our introduction. That is, we'll introduce our orbital Ziggy stack. That means we will open source our own Ziggy stack to the community. And I will share our experience about the trade-off about designing Ziggy service, and I will start with some Ziggy circuit like the Circum or the SP1 and our Ziggy EVM service. So, and this is our orbital research Twitter, and you can follow this Twitter and to get our newest research results. And this is our this orbital finance GitHub account, and this is the orbital within GitHub account. Yeah, and that's all I have to you guys, and thank you. And do you have any question about our product?
This material you can give us? You post in
Oh, sure. Yeah, I will share it to the root, and he will, yeah.
I have a question about the disputes, the challenges.
Mm-hmm.
Like who are responsible for making those disputes? Like
yeah, anyone.
Yeah, but
yeah,
like
it's the profitable process. If you challenge successful, just like the Optimist or OP rollup,
yes.
yeah, you will get some profit.
But, yes,
yeah.
I was getting to the point of asking, do you have like partners that like are constantly on top of like overlooking and getting those profits? Validators. Do you have like partners from Portal Finance that are validators?
Yeah, you mean the third-party challengers?
Yes,
right?
Yes. Do you know any of those that are your partners and it's also open source?
Yeah. And our circuit are open source, 100% open source here. You can run our SPV circuits. Anyone can run this kind of the circuits to and monitor the maker if they have any kind of the malicious behavior. Yeah, they can challenge it every time. Yeah, and we actually and in the last year we hold like bug bounty event, and we welcome everyone to challenge our maker for nearly three months. Yeah. And the protocol is now still opening now. Yeah, you can challenge it anytime.
All right, you have like a dashboard of the results of the challenges.
We have this kind of dashboard at the time, but I haven't prepared for you today. Yeah, because you need to run it locally, and you can get the dashboard. Yeah, you must run it in your own
all right.
machine. Yeah.
Like, so would be a valid grant submission to make an online, like, of this dashboard showing the states of every challenge.
Yeah.
That would be considered like a contribution.
You mean you want to contribute this kind of the dashboard?
Yeah, maybe.
Oh, sure. And we have our official dashboard. I mean, that is the notes here. Challenge. Yeah. This is our client here, and you can run the node in your local service. Yeah. I'm not sure if it has a front end here, but you can get the dashboard data in the command line. Yeah. Yeah. So any question? Yeah. So we end. Just.
It's over?
Yeah, it's
Oh,
over.
alright,
It's over.
alright. Thank you.
Okay. Thank you.